Imagine a scenario where a massive network failure, a burning server, and a completely destroyed soil sensor all happen at the exact same time on a farm. And miraculously, the plants don't even notice.
Right, which is wild to even think about.
It is, because today we're looking at an agricultural setup that is built less like a traditional greenhouse and a whole lot more like a nuclear submarine.
It really is a complete inversion of how we normally think about agriculture, you know? Because historically, farming has, well, it's always been a gamble with nature. You plant the seeds, you look at the sky, and you just, like, hope the rain cooperates.
Yeah, and that your equipment doesn't fail at the worst possible moment.
Exactly. You are entirely at the mercy of unpredictable elements.
Right. It's a very exposed industry. I mean, mud, weather, rusted parts. And then you look at the world of enterprise data centers, where that kind of unpredictability is considered, well, completely unacceptable.
Unforgivable, even. Data centers are all about guaranteed uptime.
Multiple layers of redundancy, absolute control. Okay, let's unpack this. What happens when you force those two worlds to collide? We've got this fascinating stack of architectural white papers today from an initiative in Malaysia called Ika Ladang Microfarms.
Yeah, and the mission for this deep dive is to really figure out how they are treating agriculture with that rigorous zero downtime mentality of enterprise IT.
We are so glad you're joining us for this one as the third person in the room here, because it's going to challenge a lot of basic assumptions about how food and technology intersect.
To understand how they actually pull this off, we first need to look at why someone would even want to apply server room logic to a muddy farm in the first place.
Right. Why go through the trouble?
It all comes down to risk mitigation. Eagle Adang's goal is to take something historically volatile and turn it into a fully investable, mathematically de-risked asset.
Like treating it like a financial portfolio.
Basically, yeah. And they do this by centering their whole philosophy around these physical hubs they call the AgriShack.
And reading through these specs, what immediately jumps out is how aggressively they reject typical consumer-level, like, smart farming gadgets.
Oh, absolutely.
If you've ever tried to set up a smart plug in your house, you know it's going to lose its Wi-Fi connection eventually.
Usually right when you need it.
Right. But on a farm, operations run 24/7. Their stated goal is to establish a zero-panic maintenance culture.
Meaning no midnight emergencies just because some cheap sensor decided to reboot. They're focused on converging information technology with operational technology, but doing it in a way that prioritizes survival over convenience.
I was actually trying to visualize the difference in approaches here. Think of consumer smart farming like a rowboat. If a smart screen breaks or a sensor glitches, you just grab the oars and row harder.
Right, you manually fix it.
Exactly. You manually water the crops until the tech comes back online. But Ecolidang is building that nuclear submarine. If a critical life support system fails thousands of feet underwater, you can't just row harder. You are in serious trouble.
You're done.
Right. They need a level of reliability where failure simply isn't an option for the core systems.
That submarine analogy is perfect because it illustrates a core engineering concept they use called blast radius control.
Blast radius control. Let's dig into that.
So in software design, blast radius control means you build a system so that when one specific piece fails, the damage is trapped in a tiny box. It physically cannot take down the whole application.
It's contained.
Exactly. And Ecolidang applies this to physical farming. They isolate failure so that a broken sensor or, like, a software glitch simply cannot cascade and destroy an entire crop of highly sensitive, perishable goods.
So how exactly do you achieve that blast radius control in the real world? In their white papers, they outline a highly specific three-tier architecture.
They physically and digitally separate the heavy-duty life support from the experimental nice-to-have features.
Let's break down how those tiers function, starting at the foundation. Tier 1 is, they call it the backbone.
Right. This is the immutable, mission-critical operational layer. They don't use consumer electronics here at all. They use industrial microcontrollers and hardwired communication lines, like RS-485 Modbus.
So no Wi-Fi allowed for the heavy lifting.
None. Zero. The absolute life support systems. So we're talking the automated climate control, the heavy water pump switching, the air scrubbers, all of that runs on Tier 1.
Because it is entirely hardwired and deterministic, it is virtually indestructible.
Yeah, it doesn't need to think or connect to the cloud. It just executes its core survival commands flawlessly over and over again.
Then you move outward to Tier 2, which they call the field network. And this solves a very practical problem, right? You can't always dig trenches and run physical cables across a massive property.
No, it's just too expensive and disruptive.
So for Tier 2, they use long-range, low-power radio networks, things like LoRaWAN. This handles stuff that is important but not strictly life or death, like deep water tank levels or weather stations out in the field.
And the technology they use provides a massive radio range that can literally punch through dense tree canopies and metal structures. Plus, the sensors run on batteries that last for years.
Oh, wow. Years.
Yeah, literally years. And crucially, Tier 2 is completely decoupled from the Tier 1 control logic. Meaning, if a tractor accidentally backs over a Tier 2 soil sensor out in the field, the core AgriShack doesn't care. The life support pumps just keep running.
It's just a totally separate loop.
Exactly. And that brings us to the outer edge, Tier 3, which is the periphery. This is the consumer wireless sandbox. It uses cheap, off-the-shelf sensors like basic Zigbee motion detectors, generic ambient light sensors.
So it's the flexibility layer. It's where you can, play around without breaking the farm.
What's fascinating here is how they build invisible mathematical walls between these layers. Let's say Ikaladeng partners with a university, and the academic researchers want to test a highly experimental new lighting algorithm. Ikaladeng gives those researchers a secure digital key and a read-only stream of data from that Tier 3 sandbox. That strict cryptographic wall means the academic partner can harvest massive amounts of real-time data for their studies, but they physically and logically cannot send a command backward into the system.
Okay, let me push back on this just to make sure we are grasping the absolute safety level of this wall. Let's say one of those university researchers writes a terrible, buggy piece of code that accidentally crashes the entire local experimental network.
Sure, it happens all the time.
Or let's say the farm's main internet connection gets completely severed by a storm. Are you saying the farm just shrugs it off? The Tier 1 system just keeps the irrigation pumping perfectly on its own?
It absolutely shrugs it off. Tier 1 executes its safety and survival loops locally and instantaneously. It does not rely on an internet connection. It doesn't rely on the central servers being awake. And it certainly doesn't rely on a beautiful dashboard interface being online.
Wow.
The life support runs no matter what kind of chaos is happening in the sandbox.
That is incredible. Okay, so an individual AgriShack is effectively an indestructible submarine. But if you are managing a successful franchise, you aren't just running one shack.
Right. You might be running dozens.
So if you scale this up, how do you manage multiple highly technical hubs without creating an absolute IT nightmare?
That is the ultimate scaling challenge, right? If you put a hugely expensive centralized artificial intelligence brain into every single physical building, your costs skyrocket and maintenance becomes impossible.
Yeah, you'd go bankrupt.
Exactly. To solve this, they utilize a collection topology. Rather than outfitting every shed with master-level tech, multiple shacks share a single localized compute cluster.
The specific example from the source material makes this very clear. Imagine you are running a collection of 4 separate shacks dedicated to cultivating high-yield mushrooms.
And those are sensitive crops.
Very sensitive. You have one shack entirely for inoculation, one for incubation, one for fruiting, and one for harvesting.
And to run that entire 4-shack collection, they deploy a high-availability cluster, using something like Proxmox. Basically, they take a minimum of 2 heavy-duty edge servers, like Dell Optiplex machines or NVIDIA edge nodes, and link them together so they act as a single brain. They run a virtualization layer right over them.
It's almost like a digital mirage. The farm's operating software doesn't actually know if it's running on physical machine A or physical machine B.
Right.
It just exists in a virtual space shared between them.
Precisely. So if machine A suddenly suffers a catastrophic hardware failure, say the power supply physically burns out, the virtualization layer instantly and seamlessly shifts all those critical IT services to the surviving machine B. It happens in a fraction of a second.
Meaning the farm operations don't skip a beat. Here's where it gets really interesting. They manage this entire cluster using a software management style like Ansible or GitOps, where there is one central repository, basically a master recipe for how the farm should run.
Right, a single source of truth.
Yeah. If a local system gets confused or knocked out of sync, the central system automatically forces it back to the master recipe, preventing any configuration drift. It's like a localized hive mind with a built-in backup brain.
They are solving what the industry calls the truck roll problem.
Oh, driving a technician out.
Exactly. In traditional industrial setups, if a machine needs a firmware update or a bug fix, you literally have to roll a truck. You send a technician driving out to the site to physically plug a laptop into a machine
Which takes hours or days.
and costs a fortune. With this master recipe approach, every configuration change is sent over the air securely to the edge clusters. They can patch logic bugs on those critical Tier 1 controllers remotely without ever compromising that vital air-gapped safety philosophy.
It is an incredibly elegant digital solution. But let's bring it back to the physical world for a moment. We've been talking a lot about pristine, invisible data networks, cryptographic isolation, virtualization.
The invisible stuff.
Yeah. But out in the real world, for you listening, think about it. A farm is muddy, it's hot, it's humid, it's unpredictable. How does all this high-tech IT architecture survive actual contact with physical reality?
This raises an important question about the vast difference between theoretical technology and field-tested operational technology. Your hardware absolutely must match the harshness of the environment.
Right.
So, Ecolidang takes a very hardline approach to physical infrastructure. Take their security surveillance, for example. They don't use flimsy, battery-powered Wi-Fi cameras.
It's the kind you'd put on your front porch.
Exactly, no Ring cameras here. They use heavy-duty power-over Ethernet cameras, where the power and the data run through one single thick physical cable. They run that into a local frigate and VR system.
But the way they process that video is what really caught my eye. Instead of sending all that raw video footage up to the cloud to be analyzed by AI, which takes time, eats up bandwidth, and completely fails if the internet goes down, they have dedicated AI accelerator chips, like Google Coral TPUs, physically installed right there on the farm's local cluster.
The local execution is key here. Those dedicated chips perform real-time object detection instantly. The system can immediately distinguish between a stray dog wandering near a shack and a human intruder trying to break in.
It just knows.
Yeah. And because it's processed locally, it only pushes verified, critical alerts to the farm operator. It completely eliminates the latency and the endless false alarms of cloud-dependent security.
And their approach to on-site communication is just as rugged. We all know what happens if you try to use a consumer tablet or an iPad in a hot, humid greenhouse.
It's a disaster.
The screen cracks, the battery swells up from the heat, and it becomes totally useless in a month, so they completely reject consumer screens. Instead, they use dedicated splash-proof SIP video intercoms hardwired right into the network.
It's brilliant.
I absolutely love this detail. It's so pragmatic. You don't need a fragile glass touchscreen to run a farm. You need a durable appliance with one giant heavy-duty mechanical button that you can punch with a muddy glove.
It perfectly encapsulates their design philosophy, really.
Yeah.
Zero friction, heavy-duty, always connected. A mechanical intercom doesn't need mandatory operating system updates. It never needs to be plugged into a charger. It just functions.
Okay, so let's take a step back. We've gathered all this massive telemetry from the soil sensors, real-time video from the AI cameras, state data from the heavy machinery, and it's all flowing perfectly into the local server.
Right.
But if you are a franchise operator running a massive collection of these shacks, you do not want information overload. You don't have time to stare at endless spreadsheets of raw data to figure out what's wrong. How does the system actually make sense of it all for a human operator?
They filter all this through what they call their Sovereign Artificial Intelligence Space, or SAS. And the operative word there is sovereign.
Sovereign meaning independent.
Yes. They do not ship their proprietary operational data off to a vulnerable public cloud provider like AWS or Azure. They keep the brain entirely local. Every single event, like every tiny temperature fluctuation, every time a water pump turns on, every security ping is permanently logged into a local system called Graylog.
Which essentially acts like a flight data recorder.
That's a great way to put it.
It creates an immutable audit trail, an unalterable history of everything that has ever happened on the farm.
Exactly. But, storing the data is only half the battle. The true intelligence is how they analyze it. Now, running a large language model, an AI brain, is like running a massive industrial oven.
It takes a lot of juice.
It draws an immense amount of processing power. If you try to run that AI oven on the exact same server that is trying to route your critical network traffic, you are going to choke the system and cause a crash.
Right, which goes against the whole zero panic idea.
Right. So they structurally isolate the AI. They dedicate a specific, powerful NVIDIA node inside the cluster just for the AI to live on, using software like LM Studio to run something lightweight like Google's Gemma model connected by a high-speed link.
And they run that lightweight, highly focused LLM right there on the farm. This localized AI is constantly watching the flight data recorder, looking for incredibly subtle patterns over time that a standard dumb alert system would completely miss.
The predictive maintenance example in their documentation is brilliant for this. A standard farm alert only goes off when something actually breaks, like, say, when an exhaust fan completely dies and the temperature spikes, threatening the crop.
Which is too late.
Way too late. But this local AI, it might notice that a specific exhaust fan is taking 15% longer to cool down a space and drawing 2% more power over a 3-week period.
So it deduces the motor is burning out, and it
Mhm.
instantly texts the operator a plain English alert saying the motors are going to fail weeks before it actually breaks.
That's-
So what does this all mean? The microfarm is essentially a self-diagnosing organism. It's analyzing its own internal telemetry and telling you, hey, my left lung is feeling a bit weak, you should probably swap it out, long before it actually collapses.
That is the perfect way to frame it.
Yeah.
It generates an actionable, plain English diagnostic report for the human operator, and then writes that deduction back into the flight data recorder for future auditing. It's an agricultural engine that is autonomously learning its own rhythms.
Now, this incredible local intelligence isn't just an engineering flex for the sake of cool technology. It serves a much larger, very calculated financial strategy. Because at the end of the day, a farm has to make money.
It has to be a viable business.
Right. How does this submarine architecture translate into a self-sustaining economic engine?
If we connect this to the bigger picture, this entire initiative is about completely rethinking how we extract value from underutilized land. Ecoladang is built on 7 integrated pillars designed specifically to mitigate market volatility.
Because most traditional farms just grow one thing, right?
Yeah, which means if the market price for that one crop crashes, the farm goes bankrupt. Ecoladang avoids this by diversifying. First, they generate their own clean power. They don't just buy electricity, they use advanced biomass gasification to turn leftover agricultural waste into their own power.
So the waste from the farm powers the data center that runs the farm.
Exactly, it's a closed loop.
And then they cultivate high-value niche crops. They aren't growing cheap commodities. They are doing advanced insect farming, which creates highly sought-after protein meal. They cultivate sensitive mycelium and specialized hydroponics.
Yeah, black soldier flies, for instance, need incredibly specific, stable temperatures to breed efficiently. A slight dip, and your production basically halves.
Wow.
That's why the Tier 1 life support is so crucial. It guarantees the yield of these high-margin crops.
But they don't stop at physical crops. They also create monetizable digital assets. Because of that strict cryptographic isolation we discussed earlier, they can safely sell access to their sandbox.
Right to academic partners.
Yeah, institutions like Taylor's University or biointegrators like Protenga. They will pay for high-resolution environmental data and a safe place to run experiments.
And remember that localized AI compute cluster, that massive oven of processing power.
Yeah.
It isn't always busy predicting fan failures. When the farm doesn't need all that processing power, they actually earn revenue by renting out their excess on-site sovereign compute power globally.
That is amazing. And they also solve the physical market access challenge, right? It doesn't matter how perfectly you grow a sensitive mushroom if it rots in the back of a hot truck on the way to the buyer.
The last mile is always the hardest.
So they integrate built-in cold chain logistics, ensuring the delivery keeps highly perishable goods perfectly intact, add in community skills training, and a highly replicable franchise model, and you have this incredible closed-loop economic engine.
It's total business resilience. By diversifying across those synergistic pillars, energy production, data processing, high-yield niche crops, and logistics, they ensure deep financial stability.
Because even if the market price for insect meal completely crashes one year, the farm survives because it's still making money renting out sovereign compute power and selling academic data.
It de-risks the investment entirely. The 3-tier technology is ultimately just the vehicle to guarantee a sustainable, predictable economic output regardless of external shocks.
It really is a masterclass in systems thinking.
Yeah.
So let's recap this journey for a moment for you listening. We started with the inherent vulnerabilities of traditional farming. The mud, the unpredictable weather, the constant gamble against nature.
Yep, the rowboat.
The rowboat, exactly. And we've seen how eco-letting transforms that reality using a strict 3-tier hardware isolation architecture, where the life support system simply cannot be taken down by a bad Wi-Fi connection or a researcher's buggy code.
The nuclear submarine.
Right.
Wow.
We've seen farms equipped with local AI brains that act as self-diagnosing organisms, predicting motor failures weeks before they happen. And we've seen how these spaces double as sovereign data centers, creating diverse, interwoven revenue streams that protect the entire operation from market collapse.
It definitively proves that combining raw agricultural output with enterprise-grade IT infrastructure is the key to scalable, de-risked sustainability.
Absolutely.
Whether you are looking at this from the perspective of an investor wanting guaranteed returns, a technologist fascinated by edge computing, or just someone interested in the future of our food supply, the implications are absolutely massive.
They really are.
Yep.
Which leaves us with a brand new, frankly wild application of this knowledge for you to mull over. If these AgriShacks can operate as completely autonomous, self-diagnosing, highly secure physical nodes that literally run on local waste, perfectly regulate their own internal life support environments, and refuse to fail even if the entire outside internet collapses.
Yeah.
What happens when this exact submarine architecture is applied beyond agriculture? Could this blueprint be the future of instantly deployable disaster relief shelters in war zones? Or off-grid remote hospitals in extreme environments where failure means lost lives? Could the future of resilient human survival infrastructure literally be grown out of the blueprint of a high-tech mushroom farm?
That is a fascinating thought.
Think about that. Until next time, keep diving deep.